Happy Saturday. Make sure you sign in. I'm gonna have you guys sign in again for session 2. Because I don't know if anyone's leaving session 1 and coming on Thursday for session 2, or if you're gonna just stick out for the whole thing. So my plan is 9 to 9:40. I will do the whole review of data, and then I'll give you guys a break. I hope they turn on the lights in the bathroom because they were off early. Yes, early on. So good luck with that if you have to go to the bathroom. Because it was completely dark when I went by there. And then we're gonna do multiple choice practice. 10:30. I don't know if people are coming for session 2 only, or if they're just gonna, or if you guys are leaving. So I'll give you guys a 5-minute break, and we'll start at 10:35 for experimental design. Go through the experimental design, give you another break, and then we'll do multiple choice review. And if we have time for your responses. Cool. So describing data is analyzing univariate data. Do we remember what univariate data is?
One variable data.
One variable. Creating and interpreting graphical displays. Hey, Sophia, you sign in for me, or the sign in sheet. Histograms, dot plots, stem plots, or box plots. All the easy stuff. This should be the easy stuff. And then we're going to go into bivariate data with when everyone forgets the linear regression stuff. And then for session 2, it's sampling methods, types of bias, simulations, experiments, observational studies. So, univariate. One variable, usually quantitative. Quantitative means numbers.
Are these notes by any chance printable?
I can post them. I'll post them on Edmodo and some of these. This screen manager will post. This is the same one. She has the same one. We use the same PowerPoint, so
Are we doing multiple choice?
yeah.
If you were earlier.
Height, weight, income, GPA, number of cars, number of states you've visited, number of cats you've owned, number of dogs you've owned. Those are all numbers. So that's all univariate data. When you ask to describe, what are you supposed to say?
The string.
That's for bivariate, yeah.
Oh, sorry. Never mind.
You're on the right track though.
Was it
Or
soft?
Shape.
Shape.
Center shape spread.
Center, shape, spread.
So
What's G-socks?
G-socks.
Remember? No, we don't remember
What's that?
G-socks.
Yeah, G-socks.
Gaps,
Spread.
spread, center. O is outliers.
Outliers.
Center,
Centers.
spread.
No, we said spread already.
Wait, there's two.
No, that's supposed to
Shape.
be.
My phone. Could you sign in for me? Center, shape, spread. Those are 3 main ones. Center, you give, what are some types of center that you could give?
Binomial.
Mean or median. Shape, skewed right, skewed left, approximately normal, uniform. You guys can sign in. And then spread would be range for if you're going with median, and then
and then standard deviation.
standard deviation for
Like I'm saying.
for me, yeah, standard deviation for me. Cool. All right. So when asked to compare, address the center, shape, and spread. When they tell you to compare 2 things, compare the men and the women heights of basketball players. You have to address the center of both of them, the shape of both of them, and the spread of both of them. So, what's this shape? Skewed right. Okay. Hi, Jake. Good morning. Good morning. See, Chris? A lot more than 5 before. right now. If you guys could sign in for me, it's where? Come on.
Right here.
Does it look like anyone else is coming this way?
There was a big group of people, but I don't know if they were going to the senior.
Saturday school. Oh, there's also senior video.
And there's a testing.
And then there's FCAT tutoring. It looks like they're doing stuff for the play still.
Yeah, they are.
So doing stuff for the play, so all those people.
So you're gonna come to the
Why are you recording yourself?
They're gonna put this on a YouTube channel so that if you did not show up to the sessions, you can still watch it. You won't get credit for attending the session, but at least you can go back and see what we talked about. All right. Well, let me go back and give you guys our agenda, and then we'll. Sorry for people who are on time. So 9 to 9:40, I will give you the whole review, and then we'll take a break. Go to the bathroom, stretch, come back. Then we'll do multiple choice practice and free response practice if we have time. I will cut off at 10:30 and start session 2. And then, I don't know if you guys some of you are leaving for session 2 and gonna come on Thursday, or if you're gonna just stay through the whole thing. That's why I need you to sign in again for session 2, the session 2 sheet. And then I'll go over through experimental design for all of the review. We'll have another break, and then we'll do multiple choice practice and free response practice for experimental design. All right. Those of you who just came in, joined us. Univariate data, one variable, numbers, usually it's quantitative. Always, when they ask you to describe it, say center, shape, and spread. When they ask you to compare to men and women, or I don't know, cats and dogs, how much cats and dogs eat. Compare center, shape, and spread of both of them. Here, now this is where we left off. This shape is skewed right. This one? Approximately normal. We always say approximately. Yes? This? Skewed left. Bimodal, because there's 2 humps, right? Uniform. Uniform kind of looks like a box. So if it looks, what did you say?
He said multimodal.
Multimodal. Okay, so describe this distribution.
Approximately normal with one outlier.
Okay. That's a shape. You gave me an outlier.
And the spread would be from 20 or 30 to 120.
Okay, so we have the shape is approximately normal. We have one outlier at 20. Let's say it's 20. What else?
And the spread would be from 30 or 31.
When I say spread, I'm talking about what here?
The range.
The range. What'd you say, Lynn?
You're turning AP, right?
Mm-hmm.
Okay, yeah, I just want to make sure you were turning geometry. But I didn't think so.
Oh,
Okay.
those kids didn't show
That was weird.
up.
Kind of could be huge.
What are we approximating the max is at?
What's in with time?
125 to
30.
No, it'd be 20.
no, the minimum value. This is where we always mess you up. Right here to 20.
105.
I thought like when you had an outlier, then the new min was the line.
Mm-mm.
But then when you do the range, you count the outlier.
Because it's the minimum. It's the max
just when you
value
draw it.
all the way to the minimum.
Just when you draw it, that applies.
Mm-hmm.
So maybe 105.
So 125 minus 20 gives me 105. I hope my math is wonderful on a Saturday morning. Good luck. Center, wherever we want to say this is. 70,
75.
77, 78, anywhere around there.
Yeah, you gotta sign in. Wait on that, nobody listens to me.
Cool. Any
77.
questions?
Nah, you said 77.
What?
Stop complaining.
So this spread, is there anything else you can use?
For spread? Well, with box plots, we usually use the median, right?
Yeah.
This is the median value. The other spread we can use is standard deviation, and that would be for something that's approximately normal, or when we're using a histogram.
So we just
Maybe.
put standard deviation and then that, whatever standard deviation.
Or, and what's the other type of?
Isn't there, can't you use a mean at times? Or-
No, that's for.
Mean is for center. There's also variance. Variance is spread. And then standard deviation squared is variance.
For spread?
And what's the difference between gap and an outlier?
There could be gaps in your data. When you look at maybe dot plots,
Oh,
you have gaps, and it might be bimodal. Especially, I think when it's bimodal, it'll do that. So let's look at this. Let's say that it kind of separated between here. Then there you have a gap in your data. Okay. Compare these two distributions.
Both.
So this is household size. I don't know if you guys can see. Household size in 1950, household size in 2000, and then the number of households.
Okay, so the spread on the households in 2000 are smaller.
Good. You want to use, when you compare things, you want to say larger, greater than, less than,
Less.
one's bigger than, right? Any of those words that, compare.
Less.
So we said that both distributions are skewed right. What else? That's okay. Shape, check. Next.
The spread.
Spread for household size in 1950 would be greater than that of the household size in 2000.
The spread for 1950. Sorry. I'm dyslexic in the morning. What I would actually give the actual numbers and then say one's smaller or bigger than the other. So what do we say?
Yeah.
About 13. Spread for is 13, and for this, the 2000 household, it's 11. In 1950, the household's size was larger. Next. Center. What would we say the center for 1950?
Probably to the right in 2000.
Probably like 5.
I mean, we have the actual numbers. It's 1, and then this is 10, so 5. 5 and 1. I mean, you can actually calculate it if you wanted to be accurate.
It looks about 5.
But we're gonna try and do it. Next time.
There's no time.
Can we just calculate the mean?
I would say this is 5. For 2, it's 40.
40 or 35?
35.
I say 35.
It's 35.
Approximate.
And then that's gonna be 60.
95.
No, that one would be 100.
That was 100, 395.
That was 100 and then that
Okay,
was
then you know. I was trying to help you, but
Okay, miss.
I did say 35. Okay, I agree. No, that's still a big
So we
Are you
wouldn't
just
calculate,
calculating the mean?
so we wouldn't calculate outliers for this three? No.
Visually, if you could see an outlier, you would say. Visually here, does it look like there's any outliers? Gaps?
No.
There's no gaps we need to address. And gaps would usually be in the middle of the data, not if there's a number all the way out here and there's a gap, then that's an outlier instead of, unless there's, I would say more than 3 numbers or 4 numbers, then it becomes a gap. What?
no ridiculous.
What would we get for 1950?
I'd say 5.
5.
But I could be wrong.
No, dude.
What the
5?
heck?
Can we just go with the median?
Hmm?
Can we just go with the median?
You can do either one.
Why are we doing median?
Cause that's what we chose to do.
I mean, I'll be finding the median, because to find the mean, or unless you want.
Remember, median
I'll be fine with you.
is gonna split the data in half, and where would our, that's a good conversation to have, where would our mean be compared to our median on a skewed right graph?
Well, right,
The mean is pulled out.
Mean is gonna be over here, because these numbers pulled it that way. Where median is something we should go with, because it's in the middle of our data.
So 7.
So we'll go with 7,
7?
6, 5, what did you say?
6.2.
5.5, something like that.
Alright.
Here,
4.5.
4.5. So my center for 1950 was 5.5, center for 2000 4.1, or 4.5, what's larger?
1950.
Larger,
But you said greater than.
Why is the marker like that?
greater than. Semi-writing.
What?
Does Mona think she's funny sometimes?
I know. She laughing at her own jokes.
Would they
I
take
entertain
points off
myself that
if we
way.
use mu instead of x bar?
Hmm?
Would they take points off if we use mu instead of x bar?
Here, because we're just describing data, unless they said it was a sample, then you have to say it's X bar.
Things like okay.
I'm thinking here it's a population because they're talking about in the year 1950 and in the year 2000, but they wouldn't take off for using either one here. Unless they specifically said the population or sample, then you need to go with whatever symbols it is for that. Alright, so for graphs, you must know histograms or dot plots. Not histogram or dot, you need to know both. Box plots, stem plots, scatter plots, and it's nice to know ogives. Ogives we're gonna review in class because everyone, it goes over their head.
Yep.
Every time there's an ojive ever, I skip it. It's stupid.
Why?
It's dumb.
That one was the easy one on midterm.
The OJ, like, did you see that?
The other ones
It's
are
the cumulative frequency graph. That's the one that was, it was the easiest one on the midterm.
No, it wasn't.
Histogram and dot plots, pretty much they show the same thing. Except with histogram it's bars and dot plots it's dots. But they're the same.
This kid needs to go.
Box plots, you put in your calculator gives you a 5-number summary.
The dot plot, though. Actually drawing it out.
Oh yeah, it's a pain. Remember for a box plot, you need to do the 5-number summary, which is what?
Q1. No, min.
Min, Q1, median, Q3, max. And IQR is Q3 minus Q1. How do I find an outlier?
1.5.
1.5 times
IQR.
IQ. Sorry.
There you go. I knew it.
Scatter plots. When do we use scatter plots?
To describe correlation.
And spread.
What type of data do I need? Can I do it with univariate data?
No.
I need two variables in order to do a scatter plot, which we'll get into next. Questions? Remember what a sum plot is? Yes. Sometimes I forgot where we did one where it was really confusing to look at.
I think it was one of the homework problems. It was like a double sum.
Yeah, it was like a double.
Oh,
So
yeah.
they will stop you on stuff like that. Try and confuse you with just the data. Alright. Bivariate data. 2 variables. Again, they're both usually numbers. Height, weight, income, GPA, number of cars, number of states visited, number of cats owned. Maybe you compare your height and your weight to a scatter plot. Everyone's height and weight. Income and how old you are, right? Or your GPA in high school compared to your income. You would use those two. You have to use 2 variables in order to do the scatter plot. You would compare 2 variables. Well, here, Sophia, when we describe, it's
Strength,
strength, direction,
and shape.
shape.
Linear.
Shape is still the same. Yeah, direction, form, which is shape. Straight. Direction. What are my options for direction? Negative or positive? What are my options for form or shape? Curved, linear, parabolic. Strength. Strong, moderate, or last one, weak. negative or positive, curved, linear, parabolic, strong, moderate, or weak. I forgot what 9 weeks test it was. We pulled a fast one on you, and everyone forgot to describe describe direction, form, and strength. We said it in a way that you guys wanted to talk about the relationship. We said, what's the relationship of the two variables? And automatically you just started talking about, well, if the height is greater than, is going up, then the weight is going up. And yes, that's talking about direction, but you didn't say the 3 things that you needed to say. Remember that? I don't think anyone from my class got that right. You guys all got direction and then forgot about form and strength. Alright. Here. What would we say?
Strong, negative, negative,
Strong,
linear,
linear,
negative.
negative. As your x variable increases, your y is decreasing. This
Minecraft?
this reminds me of the computer game that we're playing.
Minesweeper?
Positive,
Positive,
Week.
very weak,
very weak.
And looks like a big block, can you say that?
linear,
For 4.
We could say linear, curves. You could say either one, I think, and either one they would go, because it's so weak, they would go with. A lot of these were very lenient on the shape, as long as you say it though. So if you say linear or curved, it's fine because it's so weak. My R value, do you remember what R is? Correlation. What would my R value be close to here? Because it's so weak.
0.
Like 0. Somewhere around 0. So positive direction, maybe 0.9 or something. No,
That'd be strong.
It's pretty high.
0.2. Sorry, or 1. Positive though. Here.
curve,
Positive,
very strong,
This is strong, curved, and positive. Good. This is easy. As long as you guys remember that when I say describe or tell me the relationship between the two variables, you say the 3 things.
Is there any possibility that we might get an FRQ on this? Actually,
On describe, there's usually the first, we've seen a pattern that thank you, mine was, that the first FRQ is talking about, data analysis, usually. It's the easiest one, you guys are like, okay, good, I can do this, and then they give you everything else and you're like, whoa.
there's one inference one, right?
And there has to be one.
There has to be.
There is gonna be an inference one.
Alright.
40% of the test is on inference. So, that third 9 weeks, if you did well, you have a good chance of passing.
What was the curve?
Huh? Down here.
She's laughing, she's really
I don't,
I said I did well with the curve.
you know that. It's
Oh, I
sad.
know.
Yeah, I know what you know.
It wasn't good. I don't know this. What are you talking about?
She said it wasn't good.
Yeah, it was. The third 9 week. I'll prove it.
Or maybe she's talking about what you're saying in general.
Here.
Curve,
It's curved.
Could it be parabolic maybe?
Negative parallel.
It's what's one positive?
I mean, if we say this is an outlier,
Oh, okay.
right?
Then it's good.
Isn't parabolic curved
So
anyway?
is it linear with
Well,
all?
parabolic was in the U.
Parabolic would be a U
Or the other.
or a smiley face. We could call that an outlier and then say that this is curved, right?
Yes.
When you describe, would you say that, would you tell them that you think that that's an outlier? You can go ahead and say it. I would. I'd give them all your knowledge, everything that you think, put it on the paper. That is accurate, not, I think, I don't know, no. Be 90% sure. So you can say that's an outlier. It's curved. What else? Straight,
Positive.
positive. And I would say moderately. I would say it's moderate.
So is it?
But if you say it's weak,
it's called the outlier.
it'd be fine because of all these points being.
So if there was an outlier, do you describe the outlier, or you just like circle it?
You would just say no.
Or
I think there's an outlier at the price being, to 2,400, and the quality of rating at 65. All right, Chris is interested in buying one of the 14 sewing machines. He will consider buying only those machines for which there are no other machine that has both higher quality and lower price. On the scatter plot reproduced below, circle all data points that correspond to machines that Chris will consider buying. This was enough for Q. Thought we did that. Didn't we do this sometimes?
Wouldn't it be a Does it have to be many or?
It says circle all data points.
That one.
Someone go up here and circle. Because I don't know where you're pointing. Unless you tell me what the numbers are. Then I can circle.
Like
I remember
81,
81.
the 81. The
Quality of
the highest
81.
one.
Highest points.
Well, I'm not telling you the answer.
Well, let's circle the 65 one.
Maybe at the 971.
Like right there, right here.
I don't know.
Below.
I mean,
No.
This one? That one's the one you
why
said?
would you consider buying any other
Yeah.
one besides the top one?
Yeah, like it has a better quality and a better
Right.
rating. So
Realistically speaking.
yeah, like it's
Good job.
Yeah, that'd be it.
That's it, right. Because this is the cheapest price and the highest quality rating out of all of our machines. Alright, what is correlation?
Direction and
Is
strength.
the strength of the relationship.
The strength of the relationship. Measures the strength and direction of a linear relationship. It's between -1 and 1. That's when we were talking about, if R is 0, that means it's very weak. It looks like a big 0 circle. And all dots in between. If it's 0, you can't really tell if it's positive or negative. Slope and y-intercept sentences that you need to remember, because there will be one of these questions on the test, on the AP test, and they will ask it somewhere on the multiple choice or on the free response to just say the slope, describe the slope, and the y-intercept in context. So, as the x variable increases by 1 unit, we expect the y variable to increase or decrease, depending on what your direction is, by the slope units on average. Do we remember what our equation is?
Y equals a plus bx.
A plus bx. What is slope?
The a. The big B.
That's slope. And then this is my y-intercept. This is,
I think you write a sentence like that, even though you just describe the slope.
Mark, mark.
Okay.
Like, you're just describing the slope, you would write a sentence like that, or you could say the slope is, like, like a given number for a slope.
you need to put it in context. They're gonna ask, find the slope and put it in context. They won't just ask for the slope. The y-intercept. When the x variable is 0, we predict the y variable will be the y-intercept, whatever that is. So the a value. Most of the time, sometimes, I'm not going to say most of the time. The y-intercept usually doesn't make sense.
Explosion. If the y variable, the y-intercept doesn't make sense, do you say that there's like a, what they call it? Explosion. I don't know what it's called.
Extrapolation.
Yeah, extrapolation.
Extrapolation is, yeah. You can say, because if our data's completely away from the value of 0,
Yeah.
extrapolation is when it's not in your data set. You're trying to predict something that's not in your data set. Good. You were concerned. You were concerned. Alright, we're almost done with this, and then we'll get a break, and then we'll start practice. R squared sentence that you need to walk out of this room and graduate remembering for the rest of your life. Oh, so one thing I want you to remember. R squared is the percent of the variation in whatever your y variable is, accounted for by the least squares regression limit of the y variable on x, of y on x. So let's say R squared is 90%. My y variable is
What was your question?
I'm trying to make something up.
Oh.
Y is gonna be
GPA.
and x is hours of social life.
You're gonna put it
Hours of tutoring.
4.0 equals 0.
So 90% of the variation in GPA is accounted for by the LSRO of the GPA on number of hours studied. Number of hours for tutoring.
Do they usually give you R squared, or do you have to find it?
They'll give you R and then you have to square it, or vice versa. R is called what?
Correlation.
Correlation. R squared is
Variation. Right.
Correlation squared.
correlation coefficient.
Oh yeah.
Remember?
Yeah.
Correlation coefficient. So if they ask what is correlation coefficient,
That's
you have to, they'll give you R, or how do we calculate R?
Wait.
It's in the reference sheet, do you remember?
Isn't
No,
it
we can
also
look it
in-
up.
Isn't it also in the data?
It's in the calculator.
Yeah.
Yeah. You do the LSRL formula and it's just there.
Yeah.
Sometimes they won't they won't give you all the data, so your calculator can't do it. Sorry, you can calculate B.
Oh, I don't
R, and then the standard deviation of y over the standard deviation of x. Remember, rise over run for slope times your correlation gives you your b value. Sometimes they'll give you your slope and your standard deviations, and you can look for R, or your calculator gives it to you. If you blank out on the test and you refuse to remember the sentence, I'm pretty sure somewhere in the test it's going to be. This sentence will be somewhere. Look for it in your multiple choice. Look for it in the free response. It'll be somewhere. And you'll just, maybe on the multiple choice they'll ask, what is the percent of variation in, and then they'll just pretty much say the sentence, and they're really just asking for R squared, but they just gave you the sentence, and then in the free response they'll ask you to say the sentence. Well, you found it, it's somewhere in your multiple choice part. Residual plot. The residuals are the observed minus predicted. Wrong. I haven't heard that one. Wrong. Residual observed minus predicted.
Oh.
That's the first time you've heard that too?
No, we do that
Like in
experiments.
fairness
Oh,
classes,
no, I haven't heard that before.
there was a big discussion about like changing it to something else.
Oh.
So that's why it's kind of funny.
Why didn't you tell us that?
What do we want to see in a residual plot? No
No
pattern.
pattern.
No pattern.
And it's wrong.
And watch out for extrapolation. We want to see no pattern. If there's a pattern, bad news bears. Bad idea. It's bad, 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 bad.
So when there's no pattern, then you can say that the correlation is strong.
What are you laughing?
That the line that you created,
It's linear.
yeah, that it's okay to use.
It's a good model.
It's a good, there we go, model. Certainly for me too, sorry. Saturday I'm usually asleep at this time. Sleeping.
You're usually asleep, sleeping.
My comfortable bed. Alright. Using a least squares regression to make prediction outside the range of your data, the domain of your data is an extrapolation. Domain is your x values. If you forgot that from algebra. Alright.
Wait. Alright.
Okay. Slope.
35.
No.
As X.
Slope is always
Minus
next to
this.
your x value.
Yeah, I'm sorry.
This. So interpret the slope. So the sewing machine, as the price increases by $1, we expect the quality rating to increase by 0.02 on average. Y-intercept.
When
Well,
something is 0.
What's the x? Remember the amount,
Price.
the price.
when
So
the price is 0,
when the price is 0,
we expect
The quality rating is 35.
is 35. If it's a free sewing machine, then the quality rating will be 35.
interesting.
58% of the variation in quality rating is accounted for by the least squares regression line of quality rating on price. Hold on, I'll be right back. Yeah, you guys, this is your break.
I'll be right back.
You have to stop the video now.
And cut.
Cut.
Push it